Okay, so now we're going to pick up graphing. So the first thing we're going to do, what we say, we found that information. We're going to draw our axes. And now our axes are going to be based off of some of our information, so our shifts and things like that. When you're doing this, I'll give you another hint before we start. Draw it so it looks nice. This does not have to be to scale. And in fact, it probably won't be to scale. So since my vertical shift and my horizontal shift are both at 0, I know that the origin is going to be important, so I'm going to focus this on the origin. I will show you when that is not the case. So I'm going to put a mark here at the origin. Now I'm going to count up by the intervals. Now I want to go back to, I know this was from the previous video, but this picture here. So when we plot our trig function, or specifically in this case sine, we're going to graph 5 points for 1 period. Each one of these distances is an interval, and so that's why the intervals are so important. And notice that I have 4 little squigglies there. That's because we divided the period by 4. Alright, so for 1 period we're going to plot 5 points. If it was 2 periods, we would plot 9 points, because there's going to be a point that overlaps between the two. The beginning and the end of a period will be the same point. Okay, so let's look at this. Alright, so we are trying to graph 2 periods. Whoops. So I'm going to make 9 tick marks, including this. So this is 1, then I'm going to do 2, 3, 4, 5, 6, 7, 8, 9. And all I'm trying to do is I'm trying to kind of make them look evenly spaced apart. Doesn't have to be perfect. Those are my intervals. So what were my intervals, or those are how I'm going to count by my intervals, what I talked about in terms of my strategies. So this was 0, so this is pi over 4. This is 2 pi over 4, but I'm going to reduce that to pi halves. This is 3 pi over 4. This would be 4 pi over 4, so that's going to be pi. Then 5 pi over 4. Then 6 pi over 4, which is 3 pi over 2. Then 7 pi over 4. And then 8 pi over 4, which is 2 pi. Okay? Now I'm going to put a mark for my amplitude. What did we say our amplitude was? That was 3. So that means from the middle, the midline, which in this case happens to be the x-axis, I'm going to go up 3, and I'm going to go down 3. So now I'm just going to plot the points for the sine curve. So this is 1, and all I'm doing is I'm following that shape that we saw before. So that's 1 period. We're doing 2 periods, so I'm just going to continue on with that pattern. So I go up, middle, down, middle. And I just kind of draw the curve. So that right there is 2 periods of this function. Questions? Okay, let's do another. Okay, so for this one, I want you to try to find this information first. We have y equals negative 1/4 sine of x over 2. So I want you to pause the video, just try to find the amplitude, the period, the intervals, the vertical shift, and the horizontal shift. Unpause when you're ready to check that, and then we'll graph it again together. So pause the video. Okay, so we got amplitude is 1/4, period is 4 pi, intervals are pi, vertical shift is 0, horizontal shift is 0. Just to go over that, remember the amplitude has to be a positive value when I'm talking about amplitude. The negative is going to affect the graph when we actually do the graph, but in terms of if I said what is the amplitude is positive 1/4. The period, we do 2 pi divided by b. We need to recognize that the b value here is 1/2, so I have 2 pi divided by 1/2. That is not the same as 2 pi divided by 2. So remember, I actually have to multiply by the reciprocal of the denominator, and that's how I get 4 pi. The intervals are the period divided by 4. That's pi. Okay, So now, again, I want a couple of things to think about. The horizontal shift and the vertical shift were both 0, so the origin is going to be the start of my graph for this. So that helps me in terms of drawing my axes. All right, so I'm going to put a mark here, and then we're doing 2 periods again, right? So we're going to do, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9. This one's actually pretty nice because my intervals are pi, so it's pretty easy to count by pi. This is 0, pi, 2 pi, 3 pi, 4 pi, so that will be 1 period, 5 pi, 6 pi, 7 pi, and 8 pi. Now I want to point out, so far the 2 examples we've done have not had a horizontal or a vertical shift. So the period, the end of one period has also been the value of the period. By value I mean the period of this function is 4 pi. Keep in mind that will not always be the case because the period is representing a distance. So it is only going to be the value or the endpoint of a period if the horizontal shift was also 0. Alright, so just keep that in mind. And our amplitude was 1/4. So I'm going to put 1/4 and -1/4. I want to emphasize again, notice that I'm just trying to kind of make these evenly spaced out. I am not trying to do this to scale. I'm not putting like 1 and then trying to figure out what is 1/4 of that distance. I don't care about that. I'm just trying to make it look nice right now. Okay, so we've got everything labeled. Now we're going to plot points. So we're going to start at 0, 0. And now this is where the negative is going to come in. So think about, what does a negative in front of a function do? Well, it reflects the function. So what does a sine function normally look like? Normally the 1 period of a sine function looks like this. So if I reflect that, it will look like this. So all that does is just change slightly, instead of normally, so I start here on my midline, and then normally I would go up at the next interval, but now I'm going to go down. Sorry, I wanted the blue. Then I go back to the midline, then I go up, back to the midline. That's 1 period. Continuing with that pattern, I go down, back to the midline, up, back to the midline, and I draw my beautiful sine curve. There we go, 2 periods. Looks nice. Thank you. Alright, next one. Now we're stepping it up. Boom, we got a lot going on here. Okay, same thing though. I want you to actually try this on your own first. You don't need to graph it, but just try to find the amplitude, the period, the intervals, the vertical shift, and the horizontal shift. So pause the video now. Try to do that. Unpause when you're ready to check. Okay, so hopefully we end up with an amplitude of 1, a period of pi, intervals of pi/4, vertical shift is 1, and horizontal shift is -pi/2. Okay. How do I get that? Just emphasizing, alright, so the amplitude comes from the number multiplied by the trig function. There's nothing written there, so it's implied that there's a 1 there. The negative, again, will affect the graph, but not the amplitude, so that's 1. The period is 2 pi divided by b. That's my b value. 2 pi divided by 2 is pi. The intervals are the period divided by 4. The vertical shift is the number added outside or in the front or the back. So that's the 1, and then the horizontal shift, I got this by setting what's in the parentheses equal to 0 and solving for x, so I got -pi/2, so I'm going to shift left pi/2. Okay, now this is where things get fun. So when I'm graphing this, again, I want to make this nice for myself. So the very first thing I'm going to do is I'm going to just draw a horizontal line. And now I'm going to put in those 9 tick marks. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. The horizontal shift is my starting tick mark. So that's going to be -pi/2. Now I'm going to add the intervals. So here I need to be comfortable with fractions, right? So what is negative pi over 2 plus pi over 4. Well, I need to get a common denominator. So this is actually negative 2 pi over 4. So I can think of that as negative 2 pi over 4 plus pi over 4 is negative pi over 4. Okay, I'm not going to go through that work every single time. But that's the work that I'm doing in my head. So this is going to be negative pi over 4. Then I'm going to add pi over 4 again. And so that's going to be 0. And then I'm going to add pi over 4, which is pi over 4. And then I add it again. That's 2 pi over 4. So now, at this point, I can start counting, right? So 2 pi over 4 is pi over 2. And then I get 3 pi over 4. 4 pi over 4 is pi. Then 5 pi over 4. And 6 pi over 4 is 3 pi over 2. Those are my marks. Okay, next thing. Now, what was our vertical shift? Our vertical shift was 1. So I'm going to label this 1. Here I can put in the rest of the axes, right? But I'm saying that this line right here is 1. That's okay, as long as I label it. Okay, now my other option would have been, so I'll show you the other option as well, if I can quickly change this. My other option would have been to draw in a dashed line and call this 1, right? And then I'm implying that the black is the x-axis. It doesn't matter which one you choose to do. I'm going to label this as 1. What was my amplitude? My amplitude was also 1, so that means that I'm going to go up 1, so this is going to be 2, and this is going to be 0, or this is actually the x-axis down here. Now this was a negative sine curve because of the negative. So with a sine curve, we always start out at our vertical and horizontal shift intersection, which is 1 negative pi halves. But since it's a negative sine curve, I'm going to go down first, back to the midline, then up, back to the midline. That's 1 period. So notice that the distance from negative pi halves to pi halves is the distance of the period, which is pi. That is a distance of pi. But neither of those are the value of pi. All right, then I continue on. And then now I draw my curve. Okay, and so this one hopefully gives us a better idea of really understanding that the intervals and the period are distances. Also the idea of make the graph look nice. Alright, last one. I want you to try this whole thing on your own. So fill out the amplitude, the period, the interval, the horizontal shift, and the vertical shift, and then try to graph 2 periods of this. So pause the video, do that, unpause when you are ready to check the whole thing. Alright, so hopefully we got that the amplitude is 2, the period is 2, the intervals are 1/2, the vertical shift is -3, and the horizontal shift is also 1/2. I wanted to point out this is a coincidence that those are both 1/2. It is a coincidence that the amplitude and the period are 2 as well. So don't let that confuse you. Here's my work on how I got any of that information, if you are confused on that. Horizontal shift is maybe the trickiest one, so I set what's in the parentheses equal to 0. Again, your other option would be to factor out pi. That's how I got the 1/2. Now, I intentionally graphed this one slightly different than the previous one, so just to show you, and I talked about this on the previous one. So here, what I did first was I just drew the x-axis, knowing that that is not my midline. And knowing that my horizontal shift started at 1/2, that is my first mark. So I don't care about the origin here, I'm just spacing something to the right of that. Then I emphasized below the x-axis because the entire graph is going to take place below the x-axis because of my vertical shift of -3. I'm going to have an amplitude of 2, so I go up to -1, down to -5. I start my graph at the intersection of the vertical shift and the horizontal shift. This was a positive sine curve, so then it went up, midline, down, midline, up, midline, down, midline. Again, you could have just drawn just drawn one line and labeled that as -3. That's your other option. That's graph and sine.